video, we want to discuss the domain and range of our trigonometric functions. So, for example, let's just start with the trigonometric function f of theta equals sine theta. Then what we're inputting into the trig function is an angle. So our domain will consist of angles, because domain are input. Now, an important distinction here, and a place where we really need to be careful, is angles can be represented in either radians or degrees. But anytime we consider trig as a function, we're considering that angle to be in radians. So our domain will consist of all the radian angles that we can plug into sine theta. So if we look at, say, a triangle here on our rectangular coordinate system, and we have that angle theta, which we're trying to compute the sine of. So certainly we could have theta, any angle there between 0 and 90, or since we want to think in radians, 0 and 2 pi. We can also go around and around, so we can go between 0 and 2 pi, and we can go greater than 2 pi, and we can keep going around, right? So we have all the positive values of theta. And then we know we can also go trace the unit circle negative. So we can also have negative values for theta. So what we discover then is the domain of sine theta is all real numbers. We can plug anything into that sine theta. So we have negative infinity to infinity. To consider the range, I want to think about what kind of values can sine output. Well, sine is opposite over hypotenuse when we consider it in this definition with the triangle. Then so sine theta is the opposite side over the hypotenuse. And now the way triangles work, the hypotenuse is always the largest side. So this value here has to be less than or equal to 1 because it's a ratio of a smaller number over a larger number. Possibly smaller, but definitely not bigger. So it can have 1. And then it's also possible that the triangle has a negative value for the opposite, if that y value there is some sort of negative number. So it's sine theta also can't be smaller than negative 1. So our range for f of theta equals sine theta is negative 1 to 1 inclusive. We can get a value of 1 and we can get a value of negative 1. So this is one way to think about the domain and range of sine theta. Another way might be maybe you already know what the graph of f of x equals sine x looks like. So if I think about it right here, my x and y axis, the graph of sine x looks like this, where those x values are the inputs of the angles. So that's from 0 to 2 pi there, and pi there. And my highest value is 1, and my lowest value is negative 1. So if we look at this, where f of x is sine x, I can see that my range, which are all the y values covered by the graph, has to be exactly negative 1 to 1. And the domain, which here are the x values that are covered, are all real numbers. So the domain, again, is negative infinity to infinity. For f of x equals cosine x, this will work in the exact same way as f of x equals sine x, and you can easily see that the domain of this function will be all real numbers, just as it was with sine, either from knowing the graph of f of x equals cosine x, or understanding that it's the same as those input values as you go around the circle in either the positive or the negative direction. For the range, again, this instead of being opposite over hypotenuse, this is adjacent over hypotenuse, and we also obtain that the range of cosine x is negative 1 to 1. Or again, you can think about it if you already know what the graph of f of x equals cosine x is. And now for f of x equals tangent x, from our trigonometric identities, we know that tangent x is sine x over cosine x. Our range here, because we'll have all these possible values, will actually be negative infinity to infinity. the domain of f of x tangent x, we need to consider that the cosine x is in the denominator, so we need that cosine x cannot be 0. So in order to figure out where cosine x is not equal to 0, we'll actually solve where is it equal to 0, and we'll know that those are the x values that we cannot have. So cosine of x has a value of 0 when x is pi over 2, right up here. And we also know that, and we have to account for going around the circle maybe more than once to get to that pi over 2. And that's why we add that 2 pi n for multiples of 2 pi to be added. Now, that's not the only value where cosine x is equal to 0. It's also equal to 0 down here at x is 3 pi over 2. And again, I need to account for all the multiples of 2 pi n that can be added on. And both of these can be condensed into x is equal to pi over 2 plus pi n for every half circle. So it looks like this. We can go to pi over 2, then to 3 pi over 2, and then all the half circles will include pi over 2 as well as 3 pi over 2. So what we have then for the domain of tangent is that x cannot be pi over 2 plus pi n for any integer n. That's the domain of tangent x. For cosecant x, we know that that is equal to 1 over sine x. So the range then has to go from negative infinity to negative 1, because I'm flipping those fractions that are between negative 1 and 1, union 1 to infinity. For the domain, I need to consider when sine of x is not equal to 0, just as we did with tangent, except sine instead of cosine. So obtain that x is not equal to all the multiples of pi. For secant x, this is equal to 1 over cosine x. So it'll have the same domain as tangent, where cosine x can't be 0. So that is x is not equal to pi over 2 plus pi over n. And then for the range, it'll work similarly to cosecant x, because again, I'm taking the reciprocal of those fractions between negative 1 and 1, and I get negative infinity to negative 1, union 1 to infinity. For cotangent x, this is 1 over the tangent of x, which will then be the same as cosine x over sine x. So it'll have the same domain as cosecant x, because it has a sine x in the denominator. So that says x cannot be the multiples of pi. For the range now, I'm thinking of 1 over tangent x, and tangent x has a range from negative infinity to infinity. So when I take the reciprocal of all those numbers, I still obtain a range of negative infinity to infinity. And there you have the domain and range for all 6 of the trigonometric functions.